Hello everyone, so we are from Team Voyager. We'll be explaining about Doppler navigation as our aircraft navigation system. So as for part A, I will explain what is actually Doppler navigation system. Doppler navigation system is a system where it uses Doppler effect to determine the ground speed and drift angle without any external ground or satellite reference. So let's look about the working principle. Now, the aircraft will send a signal to the ground and the signal will be reflected back and received by the aircraft. So, there is where the Doppler shift happens. Doppler shift happens where the frequency of the reflected signal is different from the transmitted signal. The system measures the frequency shift and uses trigonometry to calculate the ground speed and drift angle. So the operating frequency for the system is, it operates in Ku band, where the frequency range is from 13.3 to 15.7 GHz. This frequency is chosen because it provides a precise measurement and allow for a compact antenna design fits. Now we will look about the system components, which we have transmitter, antenna, receiver, frequency tracker, navigation computer, and finally the display unit where the pilots can see the ground speed and drift angle. Now we will see which is the best phase for the system to work. So this system is the best to be used in an en route phase or approaching phase, and not best and not suitable to be used during landing phase, because this system works the best during en route because it can accurately navigate over any featureless terrain and any weather condition. No matter it rains or snow, this system can work. Besides that, it gives a continuous ground speed data that support the instrument approach, but it cannot use during landing, because as soon as the aircraft goes nearer to the ground, this system can no longer get the reflected signal and it no longer be the accurate data. So it can never work when the altitude between the ground and the aircraft is too low, which is during landing. So the best to use is during approach or during en route. So about the pilot interaction, the pilot enter initial position into the navigation computer. Then pilot can view present ground speed, drift angle, and current position coordinates. Next, pilot program waypoints into FMS and the system calculate distance bearing to the next waypoint. And finally, pilot cross-reference Doppler-derived position against other navigation source to verify accuracy. Next, we will continue with the part B, which is the operational performance and analysis. About the coverage range, no external range limit and no line of sight or to the ground station is required. So for the best altitude to be used is minimum 5 to 10, 50 to 100 feet. The maximum is 50,000 feet. And the optimum altitude for the system to work for the best accuracy is 500 to 10,000 feet. Next, we will look into the accuracy analysis, where the ground speed is plus minus 0.5% or better, drift angle is 0.5 degree to 1 degree, and the position error is just 0.5 to 2% of distance traveled. So what affect the accuracy is the terrain type. The best terrain is actually rough terrain, which is the forest or any waves. And a good terrain is actually agricultural land or hills, and this system works the worst, not really that accuracy at calm water, smooth desert or snow. We will next look the other factors that affect the accuracy. The first one is the banking or pitching changes the beam angle to the ground. Besides, climbing or descending would normally cause some errors. And finally, the older analog system have around 1 to 2% of error. This operational limitation causes the aircraft altitude limitation, terrain issues or position drift. Next, we will move to the part C, which is the comparison of the system. For the comparison, we have chosen GNSS, which is Global Navigation Satellite System, and VOR, VHF Omnidirectional Range. As comparison, there is a table where you can see the comparison decision metrics between Doppler navigation, GNSS, and VOR. So the first one is about accuracy. Doppler have good accuracy, where GNSS is excellent accuracy. Meanwhile, about coverage, both Doppler and GNSS give an averagely good accuracy and coverage, but not with VOR. VOR is very limited. About the infrastructure, for Doppler navigation, there is none infrastructure needed. But for GNSS, we need satellite, and VOR, we need ground station. So in this aspect, the Doppler navigation give the best And next, we will look about the route suitability. For Doppler navigation, it is excellent, GNS excellent, and VOR is good. Approach suitability, Doppler navigation is just moderate. Meanwhile, GNS is excellent with SBAS. And finally, about the landing suitability, Doppler doesn't really give any pros here because Doppler can't be used at low altitude, while DNS gives the excellent accuracy for landing suitability. Next, we will move to the comparison side by side between Doppler system and GNSS. The Doppler advantage over GNSS is it is immune to jamming and spoofing, no satellite dependency, while GNS advantage over Doppler is superior absolute accuracy and GNSS provide absolute position without drift over time, and it support precision approaches. Meanwhile, Doppler could not use for approaching. The disadvantage of GNS is it's vulnerable to interference. Signal can be jammed and it requires satellite visibility. So, Doppler serves as an ideal backup to GNSS, but it can be replaced GNSS, but a complementary system that works when GNSS fails. Next, we will compare side by side to Doppler navigation system to VOR. The first one is the advantage of Doppler compared to VOR is no ground station required, no line of sight limitation. But the VOR advantages over Doppler is provide absolute bearing, no position drift, and well understood and widely available worldwide. But the disadvantage of VOR is line of sight propagation, where signal is blocked by terrain and curvature of the earth. Limited range, typically 200 nautical miles maximum, and requires ground infrastructure. So, VOR is excellent for cruise navigation in areas with good ground station coverage. But Doppler is superior for over water flights, remote area, and GPS denied environment. So now we are at the last part of the slide, which is part D, what if scenario. So this is the condition where during approach, GNS become unavailable and weather condition is too low visibility. So the question is, can the Doppler navigation system support a safe landing under this condition? So the answer for the question is absolutely no, because I have repeatedly told and presented just now is Doppler could never used for landing approach. Now let's discuss why. The first one is there's no lateral and vertical guidance by the Doppler navigation system. Second, beam geometry at low altitude, and finally, no integrity monitoring. This is why it can't be used for landing approach. Now let's dive deep into why Doppler failed, because when there's no lateral control, it cannot align with runway, and when there's no vertical control, no descent path info for the aircraft to land safely. Low altitude issue where it is unreliable under 100 feet, where the aircraft need at least 100 feet and above to get a good accuracy. And finally, no safety monitoring. This can cause into fault detection. So what system do we actually need to land safely? The first one is ILS component, which consists of localizer, glide slope, marker beacons. The second one is ILS capabilities, Cat 1, Cat 2, and Cat 3 is auto land. And finally, alternative solution are the system like GLS, MLS, and radar altimeter. So now we look how all the system work together. So during normal flight, GPS works primarily to the whole system, INS support to the system, and Doppler verify all the data given by the system. Phase 2, which is DNSS failure. During this, Doppler will give speed reference by giving the ground speed to the aircraft. INS will give motion tracking, but this could never give any support for landing capability. Phase 3 is ILS active, where ILS precision guidance and Doppler give a supporting role to the system. So here is the scenario conclusion. Can actually Doppler help the aircraft to land? It's absolutely no, because Doppler only provides ground speed, drift angle, and route position. What is missing were the lateral guidance, vertical guidance, and low altitude reliability. Without this, the aircraft could never land only relying on this system only. So, required additional system for the aircraft to land safely is ILS or equivalent precision approach system. Doppler's rules in landing is only supporting, which is providing ground speed reference to FMS. So that's all from our group. Thank you.